But just to refresh your memory, remember you have sine, which is opposite over hypotenuse. You have cosine, which is adjacent over hypotenuse. And you have tangent, which is opposite over adjacent. So SOHCAHTOA is your little quick, how do I remember this? That's easy to remember. The next piece is to make sure that you label your triangle correctly. Your labels are all going to be in reference to the angle that you're talking about. So for this first one, if I want the cosine of theta, then all of my sides need to be looking at that theta. Your hypotenuse is easy. It doesn't change. It's always the one that is opposite my right angle. Then we're going to look at the other ones. We're going to say, well, if I were standing here at theta and walked across the triangle, what would I get to? That is my opposite side. And then the one that touches theta, that is not the hypotenuse, is my adjacent side. So when I come up to something like this, the first thing I'm going to do is label my sides. Label your sides based on the angle you're talking about, okay? Then we're going to see what trig function am I talking about. In this case, they want cosine. So then we're going to refer back to our little SOHCAHTOA that we will probably write on our quiz as soon as we get it. And we're going to say I need the adjacent side and the hypotenuse. You'll notice on this one, I did not give you the adjacent side. Thankfully, we have the Pythagorean Theorem. A squared plus b squared equals c squared. And so I can use the Pythagorean Theorem to find the side that I am looking for. Remember, c is always the hypotenuse. So it doesn't matter what order you put the other ones in, it's opposite adjacent squared equals hypotenuse squared, always. So I'm going to solve for my adjacent side. I'm going to say 6 square root of 5 squared plus the adjacent side that I do not know equals the hypotenuse squared. Okay? And then we're just going to calculate that. So we're going to say 6 squared of 5 squared. How do I do that? Well, I'm going to square my 6, right, which is 36. And then if I square a square root, it's just what's inside. So when you do 6 square root of 5 and you square it, and then 18 squared, 324? Any takers on that? So. All right, so we're going to take 324. We're going to subtract my 180 over. And these are all exact, so you're not going to give me decimals here, by the way. So we're going to do this exact. This is a perfect square that hopefully you'll know, or you have a calculator. But if it was not a perfect square, you would leave it as a radical, right? This particular one is a perfect square. Square root of 144 is 12. If it were not, I want it left as a square root, just a simplified square root. I don't want decimals on this. When it's asking for the trig function, if it does not tell you to round, you need to leave it as a fraction. And that means you need to leave it as a radical. So now I have my adjacent side, which is 12. I have my hypotenuse, which is 18. I am not done. Why am I not done here? Yeah, we have a number that goes into 12 and into 18. What is it? Yeah, so divide that top and bottom by 6. Always reduce your fractions. So my answer here is 2/3. What is the ratio between the adjacent side and the hypotenuse side? That's 2 over 3. So you really just need to know your SOHCAHTOA, what those represent, and you need to know your Pythagorean theorem so that you can find all 3 sides. Once you have all 3 sides and you know your SOHCAHTOA, you're literally just going and saying, okay, cosine, adjacent over hypotenuse, give me the fraction, reduce it if you need to. So for something like number 12, I've given you one of the 6 trig functions and I'm asking for another one, all right? So the one I want you to find is sine. But I didn't give you a triangle, right? I gave you just one of your trig functions. In fact, I gave you secant, okay? And so you have to think about what secant is. Secant is one of my reciprocal functions. I have sine, cosine, and tangent up here. My reciprocal functions, reciprocal of sine is cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. So basically, I've given you two of the sides of your triangle here, okay? And I just want you to solve for the other side. I've given you two sides because secant represents a specific two sides. The secant will represent the cosine just flipped upside down, which means it will represent the hypotenuse over the adjacent side. That's what that's going to represent, right? And so if I've given you that ratio, you can use those two sides to find the other side. In this case, to find sine, I need the opposite and the hypotenuse, right? So I'm going to have to use Pythagorean theorem here as well, all right? Pythagorean theorem, another way to write it is the opposite side squared plus the adjacent side squared will equal the hypotenuse squared, right? A squared plus B squared equals C squared. Because my adjacent and my opposite are always going to be the legs of the triangle. And of course, the hypotenuse represents C, right? So if I have two of the sides, I can find the third one, which means square root of 10, if I were to write that as a fraction, is square root of 10 over 1. So that means the hypotenuse is the square root of 10. The adjacent side is 1. And I need to find the opposite side. So I'm just going to use Pythagorean theorem here as well. I'm going to say 1 squared plus the one I don't know equals the hypotenuse squared. All right. All right, so I'm going to continue solving. I'm just going to square these and solve. So the square root of, or 1 squared is 1. B squared, remember when I square a square root, I just get what is inside. Subtract your 1 over, b squared is 9. So what is b if I'm talking about side lengths? Can't be negative, so it has to be what? Square root of 9 is? 3, all right? So that is my opposite side. What is the trig function that I'm looking for? I'm looking for sine of theta, right? Sine of theta. So the sine of theta is what two sides? I just found my opposite. I need to put that over what? Hypotenuse. I know my hypotenuse because they told me that at the very beginning. So if I'm looking for sine, then I'm going to say opposite, that's 3 over hypotenuse, which was the square root of 10. All right? Do you think I'm going to leave it that way? What do I need to do with the radical if it's in the denominator?
Multiply by the
Right, so we need to do this little process here. So it's going to be 3 square root of 10 over 10. So all of these come back to SOHCAHTOA and the Pythagorean theorem. You're going to use those over and over and over. If you have a larger calculator, especially, you have two modes. You have degree, which is the only thing we've talked about so far, and you have radian. We have not talked about, but we will. You want to make sure that you are in degree. There is a really quick, easy check to make sure you're in degree. If you don't know how to go into your formula, just do the sine of 30, okay? We've talked about it, but you don't have to know it for this test. You should get that guy right there if you are in degrees. Always, okay? So sine of 30 equals 1/2. If you get anything other than 1/2 when you do sine of 30, you're in the wrong mode, and we need to get you out of that mode, okay? And for now, as long as you can tell me I'm in the wrong mode and why, I will help you get to the right mode on your calculator, right? But you've got to make sure. So I would check your calculator before you do anything else, right? Make sure you're in the right mode. Mm-hmm. So if you have one of your three major ones. All right, so sine, cosine, and tangent, really simple. You literally just sine of 68 degrees, cosine of 68 degrees, tangent, whichever one it's asking for, you literally just plug it into your calculator. It says round to the nearest 10,000th. How many decimal places is 10 thousandths? It's 4, okay? Which means to round correctly, you look at the 5th decimal, and he tells you if you round up or stay the same on the 4th decimal, okay? So everyone needs to try the tangent of 68 degrees. When you round it, you should get 2.4751. All right, so just to point out for this particular one, because rounding's a big deal, it's going to be half off if you round incorrectly on something that you literally just have to put into your calculator, okay? So when you do this, it's going to be 2.47508868. It keeps going, okay? 1, 2, 3, 4, 5. This guy tells you what to do with that guy right there, all right? The 8 is 5 or higher, which means the 0 goes to a 1. That's how we got 2.4751. Now, secant's a little bit different. There's a little more knowledge here because on your calculator, you have 3. You have sine, cosine, and tangent, okay? So you're not going to use the buttons above that. That's when you are solving for an angle. You have to remember that secant is the reciprocal of which one? Cosine, opposite of what you think it would be. I know. So technically you're doing 1 divided by the cosine of 18. And that is what you can actually do in your calculator, okay? Now, if you have a small calculator and it won't do it, you can do the cosine and do the reciprocal of him. Or you can just say 1 divided by cosine. It will open this nice, beautiful little parentheses, put 18, close it, and then hit your enter, okay? It's literally all you have to do. All right, you do sometimes have a reciprocal button, which looks like this guy, x to the negative 1. All right, you have him too. So your other option is to do the cosine of 18 and then do x to the negative 1. Those should give you the same answers, all right? Again, you're rounding to 4 decimal places. So when you do this one, you should get 1.0515 if you round it correctly. This also comes back to SOHCAHTOA. So once again, we're going to use that sine is opposite over hypotenuse, that cosine is adjacent over hypotenuse, and that tangent is opposite over adjacent. When you're given something like this, you really don't need to solve for the other side. You just need to figure out which one you want to use, all right? So I'm still going to label my triangle exactly the way I did on the first page. I'm going to say, well, opposite of my right angle, that is the hypotenuse. Wherever the question mark is on these, go across there, that's the opposite side. And the one that's left over is the adjacent side. Okay, so I'm still going to label my triangle based on where that angle is. But now I am calculating the angle, which means now I need to figure out which trig function to use. But I am going to end up using the inverse trig function on my calculator. I'm actually going to use my second or my shift above the one I figure out that I'm using. All right. So now that I've labeled it, I'm just going to go to it and say, which 2 sides did they give me? They gave me adjacent and hypotenuse, A over H. Which of these is the trig function that is adjacent over hypotenuse? Yeah, the cosine. Which means if I want to find this angle on my calculator, I'm going to use the inverse cosine of adjacent over hypotenuse. So in your calculators, you're going to do your shift or your second button. You're going to do whichever trig function you figured out you needed to use. It's going to give you the inverse. It will open up parentheses, do adjacent divided by hypotenuse, right? To the nearest degree, which means the whole number, all right? So in this case, it wants 62 degrees. Nearest degree, which means you look at your first decimal place and decide if you stay or go up, okay? So in this one, it says solve each triangle. What that means is I want to know the measurement of every single angle and every single side, all right? So I want to know the measurement of angle A, of angle B, of angle C, I want to know the side length of side A, side B, side C. All right? The sides are opposite of the angles. So if this is A, that's side A. If this is angle B, this is side B, and this is side C. That's how they typically do it. The opposite sides are the lowercase for the angles. The angles are the easiest thing here. C is clearly 90 degrees because they handed that to me. B is 51 degrees. They also handed that to me. All right? For this particular one, to find my third angle, he's going to be complementary to the other guy. So all angles add up to 180. We know the right angle is 90. To find what my A angle is, it's just going to be 90 degrees minus the B angle. All right? So I can just subtract and figure out what that one is. All right? No trig involved. Literally just subtraction. All right? They gave me one of my sides. They gave me the hypotenuse side. I do have to use trig to figure out the other sides. You can do whatever you want. You can use sine, cosine, or tangent. It doesn't really matter. So if I want to solve, let's say, for B, then I'm going to say, well, if I were to walk across here, B is opposite of 51 degrees, okay? Which means I have opposite and hypotenuse. Which of my three trig functions deals with opposite and hypotenuse? Sine. So that means the sine of 51 degrees should equal my side B over my opposite, or over my hypotenuse of B, which is 14. Okay, opposite over hypotenuse. This is a basic algebra function. How do I get B by itself? It's currently being divided by 14. What do I need to do to both sides to solve for it?
Cross multiply.
Yeah, I need to multiply both sides by that 14. Those cancel. So B is going to equal 14 times the sine of 51 degrees. And you can do all of that right in your calculator. So if I say 14 times the sine of 51 degrees, 10.8800, and it keeps going. However, what does it tell me to round to?
Nearest 10th.
Yeah, so here's the thing. Your little tiny points off really add up. So if I were you, I'd get a highlighter or something and highlight my rounding. Say, oh, this is nearest degree. Oh, this is nearest tenth. Tenth is 1 decimal place, which means I'm going to look at the second decimal place. It is 5 or higher, which means I'm going to round that up, 10.9. So B is 10.9. All right. For side A, there's 2 ways to solve. What are my 2 ways to solve? So you can either do a trig function again, or you can say, well, I don't know A squared, but now I know B, so I can say plus B squared equals C squared, and you can just solve for it. Again, you want to round to 1 decimal place. When you do that, you should get 8.8. Positive goes counterclockwise. I wrote counterclockwise. Negative goes clockwise. There we go. All right, so for this first one, negative just means I'm going to start at that X and I'm going to go clockwise, all right? So all I'm looking for is, do you know what quadrant and how far into that quadrant really are we talking? So what I typically do is I'm going to start here. I'm going to go clockwise. I know I've gone 90 degrees at this point, right? I know I've gone 180 degrees here. After 180, this guy's going to be 270. So I'm not quite going to get all the way there. I only need to go to 250. So I'm going to go all but about 20 degrees of that last quadrant. That's what it should look like. This is 90. This is going to be 180, 270, 360. All right, so that's what those look like. The next one is positive, which means I'm going to start at the same point, but now I'm going this direction. I know this is positive 90, so I don't even go through the first quadrant. I go all but about 10 degrees of this first quadrant. That is 80 degrees. It says find a positive and a negative coterminal angle. A coterminal angle just means it ends at the same spot. So all you're going to do is you are going to add a circle and subtract a circle. So add a circle and subtract a circle. What is a circle in degrees? 360 degrees. Okay? So I'm going to take 195 degrees and I'm going to add 360 degrees. So a positive coterminal is going to be 555 degrees. That's one. Negative 195 degrees minus 360 degrees. A negative coterminal angle is 165 degrees. That's all you have to do. You're telling me two angles that end at the same exact spot as the angle you have been given. Add 360, subtract 360. That's a whole circle. Okay, here's the thing. The reference angle is how far away you are from the closest x-axis, all right? How far away you are from the closest x-axis. It has given you the degree measure of the angle that it gave you, all right? So all you're trying to do is figure out, do I need to go forward? Like, they're always going to be positive. So reference angles, hear me out, are always positive, all right? You're just telling me how far away from the closest x-axis you are. So in this case, you've traveled 320 degrees. The closest x-axis is right here. How much further do I need to go? Well, I only can go to 360, right? So I could say, well, you can even do absolute value here. Ignore that it's a negative, right? A full circle would get you to the closest x-axis. 360 minus 320 is going to be 40 degrees. That's your reference angle, right? 360 minus that 320, 40 degrees. Reference angles are always positive. So if I look at something like negative 110, that's what they gave me on 45. On 45, they gave me negative 110, right? About here. My closest x-axis on that one is right here, but it's only 180 degrees from where I started. So for that one, I have 180 is it will take me to my closest, so I'm 70 away. This guy would be 70 degrees as a reference angle. Reference angles are just to the closest x-axis where your angle is, and they're always positive. All right, so you're just telling me how much further do you have to go to get to the closest, or you might have to go backwards. You may have gone past the closest one and you need to go back. So these are simple. You do have to remember these, or you have to be able to draw a right triangle. All right, so one or the other. Your R will always be positive. It's based on the Pythagorean Theorem. And then make sure that when you put it into place that you do reduce your fractions. Make sure you reduce. If you have a root in the denominator, make sure you rationalize. So just make sure you do all your simplifying rules that you've done so far.